Hello guys, so welcome back. So in this video we are going to revise on measures of dispersion in statistics. So I have like practice question that we'll do, and there are so many. But first, let us go through the note, then we talk about it. So measures of measures of dispersion, we have range, we have standard deviation, we have variance, also we have dispersion. If we talk about it in a simpler term, dispersion means how is spread out is your data. So you can use range. By using range, you use the highest. You sort your data. If it's ungrouped data, you sort it from the smallest to highest. Then you pick the highest number minus the lowest number. Then that you get your range. But range has a problem. So let me show you in the example here. So this is how we do range for grouped data. For grouped data, we use the highest class minus the upper class limit minus the lower class boundary of the first class. So we will do this example. So first of all, let's do the range. So we have range, but the topic we are doing today is what? Measures of dispersion. Range is simple. Range, it does not contain a lot of math. Just probably you know how to minus, then you'll be able to do the range. We will have a range, mean deviation, variance, and standard deviation. Then we do coefficient of range, coefficient of variation. Also we will do skewness. Skewness is on measures of position. So we'll just do the four on absolute dispersion. We have range, mean deviation, variance, standard deviation. Then on the relative deviation, I think one can check out on what is absolute and what is relative, the meaning of the two words. So this is what we are covering today. Measures of central tendency. So we have the first one is range. Range is so simple, like you sort the data, like let's write it for, one is for ungrouped data. Ungrouped data, you can just call it as raw data, like 1, 2, 3, 4, 5. That is raw data. That is what we call raw data, like it does not have boundary or something. So that is the ungrouped data. The method for using that, for calculating range, we sort the data in ascending order. Then we pick the highest number somebody subscribed. Okay, we have, let me check the chart. So range is the highest number minus the lowest number. We do that in a minute. I press stream live, then I go to the studio. Here. So we have editor high. What are you doing? I'm doing like statistics, like a revision on statistics. And I'm doing this topic called measures of dispersion. So we were here, sort data, then you minus the x, which is, we represent it as a number, then x minima. So that is how we do range. Like for this example, we can do 6 minus 1 is equals to 5. So this is our range. So that is how we do range. And you are quite a researcher. No, like this topic is about you, when you're doing data science, like they force you to learn statistics first. So measures, so this is where we are. Then to be able to do a range for grouped data, let's try to do that. Range for grouped data. So we have its formula as that. So let me check for an example, and we try it here. So let's copy this and we paste it here. So this is our data set. Now for doing range is also simple. We use this formula, and what UCB means is upper class boundary. So these are our classes which are here. Here when you see this number, this is the class. So when you are told upper class boundary, you are supposed to go to the last class, this class, then you do the midpoint. So if you to calculate midpoint is so simple. You come to your class, this one, you add 65 plus 75. So you add 65 plus 75, then you average this. To average, you divide by 2. This will give us the upper class boundary. I'm not conversant with the math, can't be able to do this offhand. So we do 65 plus 75, then we divide by 2, got 70. Now this is the midpoint, but we want the upper class boundary. So the last number I guess from here, and I guess this is 75, so we will pick 75. This is not the method, so we pick UCB is equals to 75. We pick it directly. Then lowest class boundary is equals to, I think, 10. So our range should be range 65. Let's confirm with AI. We open Gemini and we paste this. Calculate the range of this. So to calculate the absolute like number, we have to add by 5. I forgot to add that. To add 0.5. So we are told here to calculate range of grouped data, we need to find difference of absolute highest value and difference between absolute highest value and absolute lowest value in your frequency distribution. Let's break this down step by step by using pedagogical approach so you understand why behind the math. Understanding the concept. What is the range? In statistics, the range measures how spread out your data is. For a simple list of number, you just subtract the smallest number from the largest number. However, with the group data like table, we don't know exactly the individual number. Instead, we know the categories, the number classes. Therefore, we have to use the limit of highest and lowest classes. So here is how to find the range for specified table using the two commonly taught method. So method 1, we have the boundary method, which we calculated and we didn't include like the boundary kabisa, we didn't include it. So we are told step 1 is to identify lowest and highest classes, that is 10 and 20. We identified it correctly here. Then we identify the highest class, 65 and 75. So also then you identify in your data set if there is gaps. So like for here you can see 10 and 21, there is a gap of 1. But if we had 20 and also here we had 20, our range could be this, but could be 65. But now, because there is a gap, you must take this gap into consideration. So how do we take that gap into consideration? So you take your gap and then you divide it by 2, then you add it. You divide by 2, then you add on the lowest value here and the highest value here. So that is how we are able to get 66. Also there is method 2, whereby you are using midpoints. So like this is our midpoint here. But they don't give the same answer. So I think the most correct one is to use the class boundary because it's the same we have been told here. So we were saying range is not a very good measure of dispersion. Dispersion is spread, like how spread out your data is. But for range, you can see here it just takes care of the highest and the lowest value and it ignores the other individual numbers. So we can use the other methods of like taking care of all the data so that we know how spread out is it. So we also have mean deviation. So mean deviation is by let me show you here, is showing how each data is, how many steps is each data away from the mean. Let's do an example of the same data here. We have so when you're doing mean absolute deviation, so for this you the step one you need to do is to calculate the mean. Then step 2 is minus each value, like minus mean minus each value. So let's calculate mean for this data. So to calculate mean, we just add the observations So 1 plus 3 plus 4 plus 5 plus 6, 21 divided by how many numbers? 1, 2, 3, 4, 5, 6. That should be our mean. So this is 21, then 21 divided by 6, and it gave us 3.5. Then you use this, you create like a table, x minus x minus x bar. So we pick our first value, then we minus 1 minus our mean, then we have 2 minus our mean, 3 minus our mean, 4 minus our mean, 5 minus 6 minus our mean, then we get our value here. So let me do it and write the figures. .5 this gives you negative 1.5, but when we are doing like absolute values, you let me say it, you ignore the negative sign. So we have 5 minus 3.5, it gives us 1.5. .5. So the formula for calculating mean deviation, we write it as summation so we write it as summation of x minus x bar divided by n. So we do the total of this. Then we divide by the total number of observations. So let me do it quickly. 2.5 plus 1.5 plus 0.5 plus 0.5 plus 1.5 plus 2.5. So we have 9 divided by 6. It should give us 1.5. So this is our mean absolute value. Like each number is 1.5 steps away from the mean. And I think maybe we prove it. So 1 minus 3.5 I don't know if we can be able to prove this. So maybe we use AI to to do that. So here is the meaning about absolute. We are told, notice we don't care if you walk on the left or right. We care only about number of steps. That is what is absolute mean. So we don't care you moved on the left and you get a negative, or you walked on the right and get a positive. Okay. So this mean absolute deviation is the amount of steps, like amount of steps for each away from the mean. I don't know if I make sense. So we have a visualization on how to do it. So this is our mean, and this is where each and every one is standing. So I used an analogy. Maybe the word deviation is killing me. Let's Google it and see. Deviation, we are told, is the act of departing from established norm, standard, and expected way. There is this good book I use, and I wanted to like read something from there. It does not have mean absolute deviation, but that is step one. We have understood what is mean absolute deviation and how to calculate it. But now you can be able to do for grouped data. So we try to do it here. So this is our data for grouped data. So for this one, we will be able to do mean absolute deviation, the formula is the same, but we just include f to the formula. So but here we times with the frequency. So for this I had already calculated the mean, and the mean we calculate it as mean so mean is calculated by summation of frequency times x times their number, then we divide by total frequency. So this is our total frequency, the 45. So our mean should be, let me calculate and write it. So we have 1989 divided by 45 is equals to 44.2. that is our mean. Then we are supposed to do the sum this, so we should have a column where we are doing x minus mean. So our number point is 15 minus, so we write 15 minus 44.2, we get 29.2. Then the other part is 44.2, our mean, minus 26 as our x, and we should get 18.2, get 25 minus, no, 37 minus 44.2, get 7.2. The other one is 48 minus 44.2, we should get 3.8, and the other one is 42 minus 44.2, we get as 2.2. Then this is long, so 48 minus 44.2, then we have 59 minus 44.2, we have 14.8, we have 70 minus 44.2, 70 minus 44.2, 70 minus 44.2, we should have 25.8. Then we add all our values, all these values x minus y, we should get a number here. So we add it, .2 plus 18.2 plus 29.2, we should get 99. So our mean absolute deviation is supposed to be 99 divided by cumulative frequency, which is here 45. This should give us 2.2. So let's try it here. So the next thing we are supposed to do is this, as we are waiting for the answer. So my calculation like failed me. Well, so our mean deviation is 12.4. So let's check our math. I forgot to like do a column here. Which is fx like I wrote the formula correct, but math didn't work out. So let's continue. Frequency times x minus mean. This is long, so we have 25. 25 minus 44.5, we should get 19.2. Like if you don't arrange this well, they fucks us. So we do frequency, this times this. So 2 times 29.2 we should get as 58.4. So here we open our eyes. 8 times 18 and 45.6. We have 15 times 7.2. Seven times 3.8. 26. 148. So we have 25.8 times 3. 74. 77.8. Then we do our calculation. But confirm with Gemini. 58. So we should get this. So let's try. have 58 plus 145.6, 108, 26.6, 140, 148, then 77. So we should get 564, which we should have as 564 divided by 45. And the answer should be 12.53. Yep, that is okay. So that is total 1 hour of doing. We have done mean absolute deviation and range. Like for 1 hour I have just done this. So let's come up after a few minutes. We do standard deviation and variance.